Here are 4 examples of taking derivatives using the product rule. With the product rule, we take the first function and multiply it by the derivative of the second, and add to that the second function multiplied by the derivative of the first. So this first function is a product of the functions x to the fourth and e to the x. Now, I like to just write down the whole product rule here. So this is x to the fourth times the derivative of e to the x plus e to the x times the derivative of x to the fourth. Then I can just take the derivatives. I have x to the fourth times e to the x plus e to the x times 4x cubed. And then I can just factor out of this. I can factor out the e to the x and have that times a nice polynomial inside. I could also factor out an x cubed, but I didn't do that in this case. Our second example is x cubed multiplied by the natural log function. And so I like to just write out the whole product rule here. It's x cubed times the derivative of the log plus the log times the derivative of x cubed. Once I have it all written out, it's pretty easy to just take those derivatives and do the multiplication and simplify. So I have x cubed times 1 over x, that's going to simplify, times the log of x times, that'll be 3x squared. Those x's cancel, so I have, let's see, x squared plus 3x squared log x. I like to write that 3x squared in front of the log x so that there's no mistaking that I'm taking a log of the 3x squared part. And then I can simplify like that. Okay, another example. Now, the only tricky part here is where to put that half, and I'm just going to choose to drag it along with x squared. So my two functions will be 1/2 x squared and cosine of x. So I write out the product rule so that I have a roadmap for which derivatives to take and where to put them. So we end up down here with 1/2 x squared, and that'll be negative because the derivative of cosine is negative sine. So times the sine of x, plus cosine of x times, let's see, that derivative will just be x then. The derivative of 1/2 x squared is just x. And then I can simplify. And I think that's about as simple as I can get that derivative. So this last example is one where we would benefit, I think, from writing this as a product of e to the x times x to the minus 1. And that way I can write out the product rule as e to the x times the derivative of x to the minus 1 plus x to the minus 1 times the derivative of e to the x. Then I can just evaluate those derivatives in a straightforward way. E to the x times minus x to the minus 2 plus x to the minus 1 times e to the x. Then to simplify, I will get rid of that last negative exponent there, minus e to the x over x squared plus e to the x over x. And I can factor out an e to the x over x here, swap those two terms to get rid of the dangling negative sign there, and that's my result.